it's not an the week is not an administrative time, but it's felt by the Earth, which is changing its rotation by this amount of second, namely millisecond up to a millisecond. So we see over 1 year, we see two big bumps. So the top of the bumps is at the solar equinox, where we have a maximum, the maximum effect of the sun. And we see also the zero declination of the moon, which is provoking in 1 week an effect the sun is provoking over 6 months. So you see the combination of the two important parameter for the rotation of the Earth, namely the 6-month effect of the sun and the weekly effect of the moon. And we see also that again, it's another measurement of the ratio of tidal dissipation versus elastic change rate, which is 3 times 10 to minus 4 by this measurement. So we see that several new physical measurements, which has been possible over the last few years, allow to define precisely how the Earth is slowing down. And in addition of that, we know that over the 4,000 last years, so the sea level have changed less than 1 meter, which is probably going to change drastically in the couple decades to come. Now, on this basis, a simple approach is to look at an analytical model for the change in Earth's circular rotation rate and just take a parabolic shape, delta t, 1/2 of a times t square. And the parameter a is the well-known 1.7 millisecond per day per centuries. Here we see the measured value, which are going up and down around this parabola. Now, again, we see the measured value from 62 to 2011, and we see where comes the parabola and where comes the so-called NASA statistical value used as default value by Jubier's program, which are going up and down. But the point is that statistical values depends on the accuracy or the trust you can have in solar eclipse annals. And you can easily, if you don't have enough data to cross-check what is said in an annal, then you might induce weird shape relative to a relatively continuous process. Now, we see where are the two the two eclipses we discussed previously, the 1912 at 22nd and the 724 also at 22nd. And you have a center, a zero value around 1853. Now, what we plotted here is the difference between a parabolic model and the statistical values used by the NASA so far. And we see ups and down going up to 700, so more than 10 minutes shift from a parabola. Now, to come back to the problem of how one can trust solar eclipse annals, so I'm living now in this area of France called Lozère, and in Mende, you had a bishop in this year who wrote in the annals that there was a total solar eclipse. And the same eclipse has been mentioned in other annals, in Coimbra, in Montpellier, in Firenze, in I don't remember all, and in Split. And here is the list of those eclipses, and we have this impossible mention of totality. There was a total solar eclipse, because even if you change widely the delta T, you won't change much from this 98%. So it means that if you use an analytical model, you have a way of testing the trust you can have in a certain model. Another example is Honoré d'Autun, a very well-known priest in Regensburg, in his book described a total solar eclipse. And if you take the retrodiction with the help of a parabola, then you get this position for the zone of totality. But if you take the statistical model used by the NASA, then you cover another city called Heilbronn, and this is due because you have some annals called the Note alles Brunensis, which are describing a total eclipse there. The point is that at this time in Europe it was very common to have fires, and annals were destroyed and rewritten. And the point is that the version we have of those annals are after 1600, and just next to Heilbronn you have Maulbronn, just the city where certain Johannes Kepler was born. And we know that Johannes Kepler was a fan to rewrite story of eclipses, and it might well be that describing the totality over the place where he was born, that it just provoked the change in those annals to claim they had totality, while in fact it was just because he was born there, although the eclipse was in 1133. Now, in this book, which is now available on the web for everybody, and it's partially answer an important question on documents which should be on which documents should be on the web, and fortunately, so the University of Freiburg took the care of putting this document issued in 915, sorry. So, and describing the year 775 to 900. And it is in this document you find the very first mention of a solar eclipse dated in terms of the Common Era. And I think it's a very interesting point. So the document is not, it has not been written the day of the eclipse, but so probably this page has been written around 900 CE, and you can see how they were writing 800 and 10 before 50, so it makes 840. So they mention first the death of the Emperor Louis I, and here eclipse of the sun on the 3rd none of May, and the none of May correspond actually to the 5th of May, the way we're counting now, between the 8th and the 9th hour of the day, of course, solar time. So that's the first mention I know of a solar eclipse dated and observed so in Sangal. And my colleague Derive and myself so put some pressure that another very important document, the so-called Chronicon of Andreas Presbyter Bergomas, which was a document which was also in Sangal, but describing the observation of this eclipse in Bergamo, so would be also put on the web, so everybody could look freely. And here you have the URL of this document. And the very interesting point is that we were, in one book you have 840, and in this other book, instead of 840, you're speaking of indizione tertia, and indizione means so fiscal period introduced by Emperor Constantine of 15 years, and it's the 35th such period and the 3rd year of this 35th period, and the date just correspond, but we see that it just an important time in the history of Europe, where you can see when a new way of dating things were what the Christian Church used to call Anno Domini, what I would prefer to call Common Era, has been created, namely year 900. So our Common Era started not with 0, but year 900. Now, another interesting eclipse is the one of minus 128 over Hellespont, because two disciples of Hipparchus, namely Pappus and Cleomedes, claimed that he observed over Alexandria not totality, but a fifth of the sun remain during the eclipse, while it was totally covered in the Hellespont. Now, we also know that Hipparchus of Nicaea, so he was born, it's now called Isnic, would have probably mentioned, if the measurement of totality would have been Isnic, then he would have mentioned his hometown, but he mentioned Hellespont, and we don't know exactly how he performed, but thanks to this difference of 1/5, and as the moon or sun radius is half a degree, so 20% of half a degree times, and that's where the question is, how he measured exactly how the 7 degree, which make the factor 70 of the distance between Alexandria to the moon relative to the radius of the Earth, which is one maybe most creative use of a solar eclipse for the understanding of the universe seen from the Earth. The first solar eclipse reported in Chinese annals, it's dated minus 708, and on this stela it's mentioned the 7th month of Lenten, which is the Chinese period of 60 days. So Lenten is the 29th day of this period called Chiazi, and here you have the number 7, and here the moon to describe the month, so the 7th month. So this eclipse can be clearly associated with this, this date. Now, this stela is usually assumed to have been found in Chufu, but in fact it's a copy which is in Xi'an, and this photograph is due to Liu Qiyuan, a Chinese astronomer. And the point is that between Chufu and Qining, so over the years, even 150 years after the solar eclipse, some are thinking that Confucius is born in Chufu, and others are claiming that Confucius is born in Qining. So we know that they were both in the kingdom of Lu, but if you take Chufu as the solar eclipse described on this stela, then you're going to you deviate from the simple parabola, and you can ask yourself the question, was it really Chufu, because Chufu has been the more or less capital of the kingdom of Lu, or not? Because Qining was definitely well inside the totality zone. Now, last example, I would show you those 4 stela from Egypt. They have been found in Tel El Armara. This one is in now in Geneva, this one in Boston, this one in Hanover, and this one is in Atlanta. And they all are speaking of Akhenaten building his city, his new capital. It is the first, I would say, the last picture where we see Akhenaten depicted not as a human with his human characteristic, but as a sphinx, and a sphinx decoding the message of the sun sounds to me like deciphering what means the signal from the sun. The only signal the sun is able to give is a solar eclipse, in my opinion. And at the time of the solar eclipse, so Akhenaten used to be in living in Thebes, where the eclipse was only 94%. Therefore, he might also not been maybe too afraid of the solar eclipse, and interpreted himself as a sphinx, decoding this signal from the sun that that he should create a new religion and create a new capital, Aten, where it was just close to the center of this eclipse. And what is interesting is that on the stela from this new capital, you have along the border of the city, you have big stelae with dates. So normally, the way of designing dates, we're speaking of Rainier year, so Rainier year 5, and it was the 13th day of the 4th month of the Peret season, and the point is that this date could be calculated to be minus 1336, and it would be just 10, I would not say new moon, but no moon, because if the sun, during a solar eclipse, the sun is the only astral orb of importance. The moon is not seen. So it's a no moon effect for somebody not understanding the process of a solar eclipse. And what is interesting is that 10 moon after a solar eclipse is just sound like a gestation period of 10 months to inaugurate a new capital. And in fact, Marc Gabold, an Egyptologist of Montpellier, took this beautiful picture. So 4 weeks before the vernal equinox, what is exactly what this date is 4 weeks before the vernal equinox. So you just have a little wadi, namely all in the oriental side. You have the Nile on my side, and you have oriental dune of sand. And in this little wadi, you just have the sun peeping out 10 months after the total solar eclipse over this new capital. So this example shows how solar eclipse could give a new light to some aspect of human culture. So all this, the slide I've presented are available on my website under Cassini.pps, and I thank you for your attention.